welcome. In this video, we're going to model percent change using bar models. A bar model is a visual way to represent the original amount as 100%. Then we can add pieces on for an increase or cross out pieces for a decrease. Here's the basic process. First, we draw a bar model that just looks like this. We can break the bar into 10% pieces, 25% pieces, or any other convenient size. Second, we want to place the original value above 100%. And then we find each unit by dividing the whole value into a number of units. So if, for instance, we wanted to break this into fourths, we can say that's roughly here. So those would be 25% each. And we could figure out how much of the original would be 25% by also dividing it by 4. So we write these values in the units, and finally we will add boxes for an increase or cross out boxes for a decrease. Let's try some actual examples. $250 increased by 300%. So one bar is always 100%, and that's going to be the $250. Since we are increasing by 30%, the final amount will be 130%. Let's break the bar into 10 equal pieces. So now each piece is 10%. I will not write this in all of them, but we will write it in a couple. Since 100% is 250, then if I divide that 250 into 10 equal pieces, we would have that each piece is worth 25. So each 10% is 25. A 30% increase means we add 3 more 10% pieces, which are still each 25. So 3 extra pieces that are 25 each gives us 75. So the increase is $75. Now we add the $250 plus 75 to give us $325. So $250 increased by 30% would be $325. Now let's look at 28 hours decreased by 25%. So the original amount, 100%, is going to be 28 hours. A decrease of 25% means our final amount that we want to find is going to be 75%. 100% minus the 25%. For this problem, it's convenient to break the bar into 4 equal pieces because now each piece will be 25%. And then when we do that, we can divide 28 divided by the 4 equal pieces to get that each piece is worth 7. So 25% is 7 hours. A decrease of 25% would mean we would subtract 7 hours, since we need to cross one of these out in order to decrease. That gives us a total of 21 hours. So 28 hours decreased by 25% is 21 hours. Next, let's look at 80 students increased by 75%. So my 100% will be 80 students. An increase of 75% means our final amount needs to be 175%. For this problem, it's useful to break the original bar into 4 equal pieces. So now each piece is 25%. 80 broken into 4 equal pieces is 20. So each of these 25% pieces represents a total of 20. A 75% increase means we add 3 of those 25% pieces. 3 times pieces that are 20 each gives us a total of 60. So we have our original amount plus the additional 60 to get 140. So 80 students increased by 75% is 140 students. Next, let's look at $1,200 decreased by 20%. So $1,200 will be our 100%. A decrease of 20% means the final percent we need is 80%, 100% minus the 20%. For this problem, we can break the bar into 5 equal pieces. So now each of these will be 20%. When we do that, we will divide our 1,200 by 5 as well to figure out the size of each piece. When we do that, we get 240. So each of these is going to be 240. Since we're decreasing by 20%, we're going to cross out 240. So we have the full amount of 1,200, and we removed 240 to get 960. So $1,200 decreased by 20% is $960. Bar models are very helpful because they show students what is happening. For an increase, we add more boxes. For a decrease, we remove or cross out boxes. This supports students who might otherwise try to memorize rules without understanding them. As future teachers, you might ask students, what does 100% represent in this problem? What percent do we have after the increase or decrease? What size pieces would make this problem easier? These questions help students become flexible problem solvers. You are doing excellent work. The more ways you can represent percent change, the more tools your future students will have.